Welcome to Stay Curious, everybody. I'm your host, Mark Marquette. So glad that you've joined us today as we broadcast live every weekday at 4 o'clock Eastern Standard Time from our studios inside the American Space Museum in downtown Titusville. And we're pleased to bring another wonderful program to you today from our friend Steve Agid. Hi, Steve.
Nice to see you again, Mark.
Likewise. And if you are a space lover and particularly on Space Hipsters, I think you'll be familiar with Keep Calm and Set SCE to AUX, which became a real viral thing because of Facebook and the internet the last 10 years. Nobody knew anything about that
No,
in 1980 or 90, right? But
no, that's new.
Steve's going to talk about Apollo 12, and Steve, you're going to talk about why you think it's one of the most important missions ever flown.
That's right. And you're going to find out why.
Good, good. Well, we enjoy Steve's programs. Hope you caught a few of them. If not, here on your YouTube channel, just put Steve Agid's name in there. There's your name right there, mine below it there. Marty Winkle, our co-producer here. Steve, we've done over 1,400 episodes of Stay Curious, and you're pushing on a dozen or
That's
so
right,
with
yeah.
us. Thank you very much. You know, podcasts are important landscape today, aren't they?
Absolutely. It's something that everybody can get that access to. And again, it's a very intimate atmosphere here at the Space Museum. The fact that you can do the broadcast daily and have celebrities from our space program, the average person coming in here that has that background to answer the questions that our viewers may have.
Absolutely. So Steve's always prepared, got a great PowerPoint slideshow for us. We'll get to that here in just a minute, as I'm going to thank all you veterans out there, including my co-producer, Urad of Marty Winkle, an outstanding Marine, and was involved in the first wave of that Vietnam War in 1965 or something like that. Marty, is that when you were over there? We won't give away your age.
Oh, 64, 65.
Okay. Yeah, 64, 65 in there. There we got Steve Jokums joining us. He says hi to everybody. Dave Stang, he's up in Macomb, Michigan. Gary Gerald. I wonder if you got snow, Gary, in Georgia. He's in Collins, Georgia. I know up in Michigan and a lot of the Midwest got it. Tom Usiak, he's back home after came down Sunday, he and his brother to catch the New Glenn launch and had to do a U-turn.
Right, yeah.
Actually, they came down Saturday and did that U-turn.
Well, I'm going to try again tomorrow.
Thank you, veterans out there, for today. Obviously, huge out there. And I'm going to ask Steve here just a second before we get rolled up here. You are a educator at Kennedy Space Center Visitors Complex. You've been out there how many years?
Well, it turns out that this coming Friday will be 9 years as a communicator out there.
Excellent, excellent, my friend. I've been on the Space Coast about 8 and actually turned down getting in the pool out there to volunteer here at the American Space Museum. So how's the Space Center doing? It was voted the #1 tourist destination, not in America, but in the entire world.
Well, number 3 in the world, number 1 in the United
Okay,
States.
okay.
And good thing to mention, as you were talking about the veterans, this week you show proof of your veteranship, free entry into the Space Center.
That's
So for the
75
folks out
bucks.
there, that's a good deal. So this week, up until Sunday, if you show proof that you're a veteran, you get to enter.
All right. And of course, many of us locally get the annual pass out there. It's worth its weight of going and parking at $15.
Exactly, yeah. If you're going to go more than once a year, it's definitely worth it.
Absolutely.
Discounts on food and souvenirs and such, plus free parking.
There you go. 10% discount in the gift shop, that sort of thing. And never gets old out there. And I'm always impressed that Delaware North, who manages it, are always cleaning, painting, pressure washing. They're really I'm always impressed by the activity going on of maintenance out there.
Well, maintenance and also coming up with new exhibits, always trying to come up with something, putting a new spin on things, having more active programs, getting folks that are currently working on topics that are current in space to give special presentations. So there's a lot of new things going on all the time.
Excellent. So we love Kennedy Space Air Visitors Complex. They've become a Sentinel member of our museum, supporting us with a financial donation. As you mentioned, Steve, I love talking about space history. I've been Ask Marty for years. People have been saying, "Why you do it every day, Mark?" And I say, because space history is every day. There's something going on that we can captivate people with about how we educated ourselves, or how we explored, or how we saw something new for the first time. And today in space history, in 1966, was the final mission of Gemini 12. And this was I can't stress how important this mission was, that it went right, because there was some question marks about the rendezvous. Not so much the rendezvous, but the spacesuit and EVAs had been a troublesome thing on Gemini 9 in particularly. 10 and 11 didn't go as exactly as planned. So Buzz Aldrin had a lot of weight on him to test the lunar suit and techniques for the spacewalk, right?
And one of the things that he did, the recommendations to use a pool to do practice spacewalking, use tethers and such. One unusual thing about the patch, it's unusual in usual colors, the black, the yellow, and the orange. Originally, launch date was supposed to be the end of October. So they had the Halloween colors on the patch.
Did they really?
Yeah,
I
that was
that.
that was the reason that they had that in that way. So when Aldrin had absolutely no trouble doing the spacewalk on Gemini 12, that made everybody feel very, very good that we could actually not only have a good suit that could be used in space, but you could actually do something while you were wearing the suit.
Yeah, the dexterity of the fingers and so forth. He actually did 2 or 3 stand-up EVAs and took what's credited as the first selfie in space. Anyway, there's the Atlas Agena target vehicle on the left, the Gemini 12 on the right, and listening, I've heard a few Gemini astronauts that rode the Saturn V, and they said this was like a sports car. Going to space in this was like taking a sports car to space. It was just a smooth ride up there with those hypergolic fuels of that Titan, right? They were hypergolic fuels, yeah, in there, like our ICBMs are going to be loaded with. So that's enough history. We may revisit that tomorrow on Stay Curious some on there, but Steve's come up with a very good program of why Apollo 12 is one of the most important missions ever flown. So, my friend, go ahead and take it away.
Okay, we're going to start off by saying Apollo 12 going back to the moon. Now, after Apollo 11, we proved we could go to the moon. That's fine. But one of the biggest concerns we had was the landing. It was a couple of miles off. Could we not pinpoint some of those future missions? Absolutely depend on us getting to a very exact spot. And maybe we didn't know enough about the moon and what we called mass cons, with mass concentrations of the moon, how that would affect our orbits. Do we really think we could actually land precisely? Well, we gave ourselves a target. What was the target? It was going to be a spacecraft we launched a few years before called Surveyor 3. It landed successfully in the Ocean of Storms. Let's try to get within a few hundred feet of this spacecraft. And then number 1, you know that we can land accurately. And number 2, what does the moon do to something after it's been sitting on the surface for a few years? Let's find that out. So, how did they look at Apollo 12? Well, somebody mentioned, and it is Howard Simmons of the managing editor of the Washington Post said, you know, Apollo 12 is going to be the greatest anticlimax in history. You had this incredible buildup for Apollo 11, the first landing on the moon.
Absolutely.
And then there's Apollo 12.
We doubled down on President Kennedy's pledge, though, to put a man on the moon, return safe for the end. We did it twice.
Now you did it twice. But the idea is that if you just looked at it as, well, they've been to the moon already, nothing else is important. Well, the problem is, again, you went to the moon. Just landing there was a victory. just making a landing. Now you want to do something useful. You want to show that you can land where you need to land. Not one EVA, just a few. They only spent about little over 2 hours on the surface. We're going to do 2 EVAs, 2 moonwalks on this mission. We're going to deploy a big science package. We're going to start learning from the moon. That's why this is different from just landing there and, as they call them, flags and footprints. Something a little bit more substantial than that. Now we start off with the original flight crew. You'll notice this is going to be a little bit different. Pete Conrad's the commander. Dick Gordon is going to be the command module pilot. And Clifton Williams is going to be the lunar module pilot. And that's the way the mission is going to go. But fate intervened, unfortunately. And what happened was that Cliff Williams, who was a major in the United States Marine Corps as a test pilot, he was selected as an astronaut and again selected for this Apollo 12 mission. However, in October of 1967, about 2 years before the launch, he was killed in a T-38. That's one of the astronaut planes that they used to get around. He ejected safely, but it was too low and he was going too fast, and so he died on the ground. Now they had to get a new replacement, a new lunar module pilot. Now the crew wanted to commemorate him. How do you do that? So if you look carefully at the Apollo 11 patch, you'll notice there's not 3 stars, there's 4 stars. Now 3 are above the ship, and 1, you can see by the red line indicator, is below the ship. That was to honor the original lunar module pilot, Clifton Williams.
Hoorah to you Marines. We celebrated your 250th anniversary yesterday, and he's the only active NASA astronaut that was a Marine to lose his life while serving his country. Go on there.
Okay, now we have the new crew. We have Al Bean. He's going to substitute for Clifton Williams. That crew has been selected. They're going to begin their training to go to the moon. And again, the major objective on this flight, see if you can do a pinpoint lunar landing. We're going to have that landing next to that Surveyor 3 spacecraft.
And I got to interject, the crew, one of the most cohesive and fun crews of all time. They were all Navy veterans. Pete was the trainer of Dick and Al, I think, at the Naval Test Pilot School.
And they've flown, Dick Gordon and Pete Conrad flew together earlier. They flew on the Gemini 5 mission.
Yeah. And Pete actually wanted Al to be his original crew member, and because some reason Dick Slayton didn't want that, and he was fine with C.C. Williams. Handpicked these guys, Pete Conrad did, a veteran of the Gemini program.
If I remember correctly, all 3 of them got matching gold Corvettes.
Yes, they did. They had quite a lot of fun, and we'll show you at the end a YouTube Apollo 12 parody you've got to watch. Quite fun that they had. A lot of fun. Of course, Pete Conrad, just a jokester, just on the go all the time, known for his gap teeth there. And and then of course we'll mention that Pete and Al Bean later commanded Skylab missions. So very cool crew.
Okay, we're going to move on to launch day, and that launch day is coming up 56 years this coming Friday, just a few days away. Now, that was the first human spaceflight launch that I saw in person. I was viewing it from where the cruise ship terminals are right now. That was, again, midday, 11:22 in the morning, Eastern time. And the weather, I just remember, was terrible, super overcast. And, they decided to launch in those conditions. And that is pretty much what's going to set us up for the very beginning of our presentation. The mission is going to go great for the first 36 seconds. And then things are going to fall apart very quickly.
Okay, we got.
So, what are the key mission events? As we did the launch, we're just going to take a look at these key mission events that we're going to do on the mission. First thing you do, of course, is have the launch. TLI is translunar injection. That means you circle the Earth for about 2 hours, make sure all the systems are performing correctly, then burn that third stage engine again to set you on a path to the moon. We separate the craft from the rocket itself. We dock. Then we do a mid-course correction. We can't be on a perfect path. We see where we are. Let's make a small little burn to put us on a perfect course. The LOI, that's the lunar orbit insertion. We're heading towards the moon. We want to brake so that the moon's weaker gravity will capture us, and we do that first burn followed by a second one. Then we undock the lunar module from the command ship, so the command ship will circle the moon, and that will be with Dick Gordon, Al Bean, and Pete Conrad will land on the moon. PDI is a power descent. That is when they get out of orbit and start coming down towards the surface. We have our first and second extravehicular activities, commonly known as the moonwalks. And after we do that, we have our lunar module will lift off. The lunar module will then redock with the command ship. The crew will get together in the command ship again. We'll get rid of the lunar module, do a trans-Earth injection to come back to Earth, do some course corrections, separate, and then do the landing and the splashdown. So those are the key events in the mission. So after we have the launch, and as I mentioned before, we got up about 36.5 seconds, and everything is going just fine. But then everything falls apart. What happens? We have a transcript here. I don't know if you'll be able to see it pretty much on your screen, but if you can get closer, you can find out what happened. We were hit by lightning. That wasn't known exactly at the time, but figured that out very rapidly. And you can see what the crew is saying. If you look at the diagrams close up, CDR is the commander. That would be Pete Conrad. CMP is command module pilot. That'd be Dick Gordon. CC is the capsule communicator. And the capsule communicator on this mission is Jerry Carr. He's one of the astronauts. He would fly on the last of the Skylab missions. So this is the exact transcript of what is happening. So what is happening is you're starting to see a lot of alarms, and we'll see that on an upcoming slide. So right now, this first lightning strike occurs, and when this first lightning strike occurs, you're sitting a little bit, if I have my notes here, about 6,400 feet. So just about, a little over a mile in altitude right now. And just a few seconds later, 16 seconds later, at 52 seconds, there's another lightning strike. Now, each of these lightning strikes causes a problem on the vehicle. What's the problem? Well, on the very first one, it had a very, very high amount of voltage. If you could look at the slide itself, it'll tell you that they believe the lightning strike delivered about 100,000 amps and 100 million volts to the side of the spacecraft. Now, what did that do? Well, we have equipment on there, something called the signal conditioning electronics, or the signal conditioning equipment. What that does is it translates all the voltages from all of the sensors and puts it on a scale from 0 to 5 volts so we can actually use the telemetry. Well, one of the solid state elements automatically shut down the system to protect that box. When that happened, we have no data. Well, that's not good. So what do we have to do? Well, on the ground, we have our flight controller. And our flight controller, the ECOM officer, that's electrical environment and consumables, his name is John Aaron. And he makes what is called the most legendary call ever from Mission Control. And there's John right there. And he says, set SCE to aux. Now, that call is made 1 minute and 36 seconds into the flight, exactly 1 minute after the lightning strike. So what's going on? There was lots of jokes about it afterwards. We knew we were picking up speed. By the time the second lightning strike hit, the vehicle was at about 14,400 feet. And again, it's increasing in speed. What they were looking at to see where they were going is spinning, because the guidance unit, again, wasn't working because of the electronics problem. So as they joked, we didn't know where we were going, but we were making good time. Well, what happened was this switch, and I have a replica of it right here. This is at the bottom of the command module's command file.
Oh,
You'll
shut
see
up
the
there.
signal conditioning equipment. Okay, and on the left-hand side, we went from the normal mode to the auxiliary mode.
There.
Okay, I don't know.
Yeah,
Hold on,
you
okay.
can see it there.
There you
But
go.
you don't have to see me.
Okay, so what happened was this. We can't use the fuel cells. Those fuel cells that do the power, they've been knocked offline. There's one other thing we can do to power the spacecraft, and that's to use the 3 batteries we use. Now, these batteries are located on the command ship, and the command ship uses these batteries under certain conditions. Number 1, battery number C, I'll put this down. Battery number C, that is used for re-entry, primarily. A and B are used at critical functions of the life of the mission. Number 1, the launch itself is critical, so you want to make sure, think of it as a UPS system. We have an automatically battery backup. And the second is anytime we use that big service module engine, we'll have that on as well. Now, what SCE to aux essentially means is we don't want to go to the normal mode, use the fuel cells. We want to switch to those batteries. And by going to the auxiliary mode, we're going to get the power from those batteries. And when they did that, they could see that their electronics were working correctly. Now, that occurred just before we're going to end that first stage burn. So they're told, hey, why don't you go back to the main system again, since we know we're okay. And Pete Conrad says, no, let's just wait a couple seconds until the rocket stages separate.
Yeah, they're in the first stage.
Right, you're still in the first stage burn, and
Saturn
a good part of that,
V,
exactly,
accelerating quickly, and they're calm enough to do all this.
And that's the idea. That again, you don't want to rock the boat too much. The Saturn V first stage only burns for about 2 minutes and 40 seconds. A good 36 seconds of that was going normally, but the last 2 minutes, you lost a minute of data before you were able to regain it again. And it took about 14 seconds after Pete Conrad was told what to do that Al Bean finally flipped the right switch. It's not a switch you do use all that often. It turned out to be in front of Al Bean, and Al Bean would be in the right seat. And he was able to do that. But again, that occurred at about 1 minute and 52 seconds into the flight. So we only had about another 35 seconds or so before the stages were going to separate. So now that we know we're getting good data, let's give it a couple seconds, let the stages separate. We get on a nice, stable second stage burn. Then we'll go back to the primary system again. So now that we feel we're nice and safe. But that is the original, they call the steely-eyed rocket scientist, and that's how John Aaron got that name.
Absolutely. He's still around.
Yes.
And got Oklahoma State University there in Southwest. There's a lot of proud Oklahomans that were technicians that did good things in there. So, but he knew what they were talking about. Love the ashtray in the foreground there.
Oh, yeah, a lot of ashtrays. All right, so as we go through that, we can just go to...
It was an amazingly close call that you all don't know the story. This is why they're astronauts, why they were chosen, test pilots. They know they could be within seconds of dying, yet they are more obsessed with getting the correct levers, switches, whatever they can do to try and save themselves.
I do have a recording of that, but I don't think the microphone picks it up, so I don't want to try that out. But I do have the recording, and you can hear one of the first comments when they're told to set the SCE to aux. They misunderstood what they're trying to say, and Pete Conrad says, "What the hell's that?"
Yeah.
Then they repeat it, and they're trying to find the switch, because again, it's not something you'd normally be using. But to quickly analyze what happened, if you look at this, the signal conditioning equipment converts everything we're getting from all the different sensors and converts it to a way that we can actually display it in telemetry. And the main power failed when we had the lightning strike. When the lightning hit, we had a high-powered voltage, so the solid-state electronics shut down things. Think of it as you have a computer and you have a surge protector. Think of it as something like that. Shut down just to make sure the rest of it doesn't get damaged. You see the bad data readings. John Aaron recognizes that we've had something like this before during a test on the ground. And he remembered what they had to do there is get that alternate sense of getting different power. That different power would be the batteries. So you tell that signal conditioner, don't get that information. I mean, don't get that power from the fuel cells, which is the normal way to do it. Get it from the batteries. Go to the auxiliary, which would be the batteries. When he did that, everything was fine again. And then after they found out that everything was stable, then we'll go back to the fuel cells, and we'll do that for the rest of the flight.
And that's what's on his shirt there, is stay calm and set
SCE to aux.
The signal conditioning
Electronics,
equipment, electronics
equipment,
to auxiliary. And like I said, that become kind of a urban firestorm of everybody.
Exactly.
I bought it on there. Marty, you've got a good question there before we go on.
Got to find it now.
That was Tom Usiak.
Yeah, no. But why? I got it. Why wasn't backup LEM pilot Jim Irwin rotated into the prime crew like Jack Swigert for 13?
Well, I'm sorry. Why
wasn't Jim Irwin selected instead of
was
Jim
Jim
Irwin was
really
backup on the Apollo 12 crew?
That's very interesting. I do not know why he was not selected and why they put Al Bean instead.
I think they were so early in the training.
Yeah, well, let's see. At the time that switch out was made, that was 1967, is when Williams died.
Yeah.
And I don't know if I don't know what the situation was and why Irwin was not at that point and why Bean was pushed in front of him.
No, I don't think they vape in any control rooms right now, mostly parked. They smoke cigarettes. Let's see. And Cliff Watson's joined us. Hi, Cliffy. He's down in Pomona, Australia. And there's Mark Thel on there. And many of you have seen Steve do a program before, so let's just let him continue. This was, I mean, I'm not over dramatizing it. Boy, this was unbelievable. Why didn't the lightning strikes blow it up?
Yeah,
that's what I've always wondered.
Well, there's one other question that people say, and it turns out this is a Werner von Braun thing. Originally, what they said, we wanted to have one system to handle both the spacecraft and the Saturn V. And von Braun was very much against that. No, I want one system on the Saturn V, one system on the spacecraft. And it turns out, because the Saturn V wasn't affected, Saturn V, from its point of view, everything is going just fine.
Because of the instrument unit.
Because of the instrument unit.
The shortest stage and the most important, right below the slaw of the where the lunar module is.
So even though the crew couldn't see what's going on, the Saturn V rocket itself knew what it was doing and was doing everything fine. Had there only been one system, then everything would have had a problem.
There you go.
So that turned out to be a good catch by Werner von Braun in the electronics.
Marty Winkle's got another question for you.
Yeah, mostly Park is asking, due to the part of Florida, I'm surprised lightning strikes didn't happen more.
All right. If you take a look at all of the launch pads, every one of the launch pads has what we call a LIVIS system, lightning inducted voltage instrumentation system. Think of it as fancy lightning rods. If it's a fixed pad like pad 39A is right now, you'll see a very tall lightning rod at the very, very top of the pad, and you'll have a system of wires going down to protect the pad. Now, if you look at pad 39B, which is going to be used for the Artemis program or the Space Launch System, all you have is 3 lightning towers with a wiring system around and connecting these 3 pads, these 3 lightning towers. And when we roll out, right now we're supposed to roll out on January 1st, the tower will go underneath that protective awning. So you have to have some type of protection in every one of the towers. None of that came out. We also have something called field mill monitors. If you take an Explore tour, when we go to the AB camera stop, you'll see this device mounted on a tripod, and it measures the electrostatic condition of the atmosphere to warn you if there's a potential of having a lightning strike. That is what we would use. That's kept monitored 24 hours a day, every day. Now, an unusual fact is Central Florida is the lightning capital of the United States. So people ask me all the time, well, it's lightning capital of the United States. Why do you decide to launch from here? No matter where you launch from, there's always going to be something in that area. And we do have a lot of lightning. So what do? We protect against the lightning and don't launch in those conditions anymore after Apollo 12.
Interesting. Did you let the cat out of the bag and say that Artemis 2 is rolling out
That's like I said, that's
Day?
the I was saying that is the last thing I saw. I don't know if it's an official release thing, but it's a tentative, and the release date for the first launch that I think I saw was February 5th at 8:09 in the afternoon, or in the evening, I guess. But again,
Oh, let's hope it's not
again,
tonight.
these schedules change fluidly, and I know they're saying early in the year, so that's about as early as you can get is January 1st.
Absolutely. The window does open up February 5th for
Right.
the moon to be in the right position and all
So,
that stuff.
I don't know if that's the official
Hotels
date.
are already sold out.
I wouldn't be
Oh
surprised.
no, and we're gonna have our memorabilia show the 7th.
Oh, that will work out well.
So hopefully. So,
And again, that's a tentative date, or an approximate date, just like that February 5th date. We still got a lot to go. The vehicle is in the assembly building right now. It's in High Bay 3. It's on the launch platform. And again, there's a lot of testing between now and then, and we still have about a good month and a half before that potential rollout date.
Good.
Again, I don't know
All
if it's
right.
official, and it certainly can change within the next month and a half.
Interesting. All right. Keep us apprised of that. Give me
Okay.
a call. All right. Let's get to Apollo 12. We finally got it out of Earth orbit.
Okay.
Headed to the moon.
Now, one of the things people ask all the time is, well, we've been to the moon. We've already been there. Well, when we did all of our landings, we had 6 landings. All 6 are in dramatically different areas. We want to get an idea. It's like saying, imagine if you were an alien coming to Earth and you landed in Kansas. Well, we've been to the Earth.
Right.
And you've seen a cornfield, or a wheat field.
Yeah.
And then you land in a jungle.
Don't
once,
forget
and-
the soybeans.
Yeah. Or you land in the ocean. I mean, there's more to the moon. And every landing site we pick, try to make it as different as possible. So on this map, you can see the landing sites for Apollo 11 and the landing site for Apollo 12. Apollo 11, you wanted a very, very flat terrain. So you have the Sea of Tranquility. It's the first landing on the moon. You want to make it as easy as possible. Your moonwalk is going to be very short. The idea is that we don't know what we're dealing with yet, so let's make something that's less challenging. For the second mission and the Ocean of Storms, we want to pinpoint and make sure we can land accurately, and to find that Surveyor 3 spacecraft. All right, so why are we going? Well, we're going to be doing a lot of different operations on the surface. Number one, big difference with Apollo 11 is they only had that very first EVA, their very first moonwalk. We only had a few experiments, very, very basic, collect a few samples of the moon. In fact, when Neil Armstrong went on the surface, one of the first things he was going to do is what they call a contingency sample, make a very small scoop, get it, just in case they had to leave quickly, they'd have something. Now we have a little bit more time. We have an opportunity to do 2 long moonwalks, to deploy the first of what we call the ALSEP packages. That's the Apollo Lunar Surface Experiment packages. Lots of different instruments. For example, the first thing we talk about, the writing on the top is the official writing. My explanation is on the bottom with the page summary. We're going to collect contingency samples. Again, something could go wrong. Something could malfunction in the suits. We want to make sure we have some rocks or something to take home. Second, we have time now, since we have 2 walks, it can evaluate what's the best way to get around. Is hopping, is jumping, evaluate the different ways we move. Try to come out, how do we do things better? We're gonna move a lot of big packages. What's the best way to move packages in 1/6 gravity? Never done that before. That's the following missions are going to depend on what we do on Apollo 12, because the following missions are going to have more moonwalks. They're going to have 3. The equipment's going to get more complex. We're going to have lunar roving vehicles. We need to know how to be mobile on the surface of the moon. Apollo 12 is going to give that to us. We have to erect a giant antenna. That's going to help with our reception, TV receptions and such. So deploying large structures on the moon. Never done that before. we have to do a lot of pre-flight activities. We say that we think it's going to take you such and such amount of time to do this. How well did we predict that? Are things going to take less time or more time on the surface? We have to evaluate that. So when we plan for the future missions, we know that we thought it would only take 10 minutes to do something. Turns out it would take a little bit longer. Or we gave it 10 minutes. Turns out it takes less time than that. So you can more accurately plan the future mission. So Apollo 12 is doing all this for the upcoming missions. Then we're going to have core samples. We're going to not only take what's on the surface, we're going to go down a little bit, see the parts that have not been exposed to the surface of the moon, and get samples from there. Now, the second set we have right here, we have to learn more about the surface characteristics of the moon itself. How do you form and how do you do visual tasks on the moon? Remember, the horizon on the moon is a lot closer than the horizon on Earth. One of the things I do when I give my bus tours is as we turn onto State Road 3, I ask the people, how far away is that vehicle assembly building? I tell them to raise your hand, put up one finger if it's a mile away, put up 3 if it's 3, 5 fingers if it's 5, hold up 10 fingers. And normally we get a range between 1 and 10 miles from where the 405 hits the Courtney Parkway. And the idea is that somebody can guess something is a mile away or 10 miles away. And it turns out it's 5 miles away. But the idea is it's hard to judge. Apollo 12 is going to tell us when you see something on that horizon, it's a better idea of how you're going to judge where things are. Look at those visual clues we can have because that horizon is a lot closer than it would be on Earth. We have to determine the lunar module's position in real time. On Apollo 11, we had that lunar retroreflector that's still in use today. It's an unpowered thing. It's just a series of 100 mirrors that you shine laser beams on, and you can determine the exact distance to the moon within 6 inches. And that's how we know that the moon has moved about 6 feet since Apollo 11. It's getting a little bit further away from the Earth. So there you go, with the length of a human being. Now here, if you remember Apollo 11, one of the things, unfortunately, about Apollo 11 is people always complain about the video we got. It was a Westinghouse slow scan black and white camera. And the astronauts, as they're walking on the surface, look like ghosts moving back and forth. Well, we've got a brand new camera. Also Westinghouse, this is a good color TV camera. Now, there's a problem. And the problem is this. The camera was put on very late in the mission processing. And I believe they said Al Bean didn't really have much time training with it. And unfortunately, when we were changing its location, and it was less than an hour into the first EVA, the camera was inadvertently pointed towards the sun, and the tube was burned out, and they couldn't use the good color video for the rest of the mission, for the rest of EVA 1 and for Moonwalk 2 as well. So that was one of the sad things. But the next thing that we had to do on this page, 3 of 5, was exactly to perform a investigation of Surveyor 3. Again, is it within walking distance? Pete Conrad estimated to be about 600 feet or about 2 football fields away. Plenty of time to get there.
Let me ask a question. Get back up to the camera.
Yeah.
Devastating that we couldn't get videos from the moon, particularly the second EVA down to Surveyor, or it was still on a cable,
right,
100-foot cable. Do you think that contributed to the apathy that quickly happened?
One of the things,
Apollo 13 is next,
right,
and then Apollo 14, people just couldn't get into it.
I think part of the problem is I remember watching it, and when the video was stopped, they had folks from Grumman make believe they're doing an EVA so they could see what they were trying to do, simulating it, because they weren't going to get any video. And the tough thing about that is this was going to be great. Number one, it was in color, much better quality, and you're going to actually see a lot of things.
Probably prime time.
And I can have the time I think I have listed, but either way, whether it's prime or not, you're going to see that broadcast.
Right.
They're gonna put out the snippets of all the good stuff. Then the problem was with Apollo 13, that was a mission where again you were just focused on the crew coming back, and then by 14, again you got the excitement of the first mission. You were waiting for the great pictures on the second mission. You didn't get it. The third mission, after the explosion at 55 hours into Apollo 13, you got nothing from there. And by 14, again, for many people, I think Jim Lovell's wife said it perfectly. She said, if going to the moon's not exciting, how could not going to the moon be exciting? And the idea is that the fact that, you have that attention span, every one of these missions, and especially when we got to the rovers, Apollo 15, 16, and 17, everything about the landscape is different. I mean, on 15, you had the most challenging landing site.
Mm-hmm.
You had Hadley Rill, which is kind of like a Grand Canyon type thing, and you're coming over the mountains of the Apennine Mountains of the moon. And here you are. You're right in the middle. You're coming over the mountain, then you're landing, and you have like a Grand Canyon right next to you. So you're talking about a pinpoint landing where you land too early and you're on a mountain, you land too late and you're in the bottom of Grand Canyon. So targeting the landing, everything we proved on Apollo 12 really set you up for things in the future. And yeah, I think if that camera was active and people could see everything that we're seeing there, the good thing about the exploration, and the one thing that's different about this and a lot of other programs, you say, when people do cancer research, there's not a channel you can turn on TV and watch the cancer researchers doing research every day.
Right.
You don't see that. You don't see that in a lot of different areas. In the space program, you see the folks at work. You're there. When you see that first picture of Mars coming down, you're there, just like the people in Mission Control.
Uh-huh.
So when Viking landed on Mars it took that first picture, you saw it the same way that the chief scientist saw it at the same time. You're a participant in what's happening. History is being made, and you are an eyewitness. You don't see that in other industries.
No, you don't. You don't. It's space is communal. I, of course, am an amateur astronomer all my life. I've put telescopes on sidewalks hundreds and hundreds of times. I've never seen an amateur biologist dissect a frog in front of a bunch of people on the street, for example.
When you set up telescopes, if you ever set up telescopes, you show it on Saturn for the first time, and people look at it, it's a dot.
Yeah.
Why don't you look through the telescope? And it's like, it has rings.
Yeah.
Well, you knew Saturn had, but it really does.
Yeah.
And that's, people don't see. People talk about astronomy, and there's a wonderful book about that, and it says, what is different from astronomy than anything else is if you stay out, there's certain times of the year where you stay out from sunset to sunrise. As the Earth is turning, you could actually go from one end of the universe to the other in a single night.
Yeah.
Explore everything in between if you knew where to look.
Absolutely. Well, that was to you can't be what you can't see, Sally Ride says, and for Apollo 12 for that camera to mess up, oh my gosh, though back here it just what could have been. And would it have inspired people more to see Al and Pete, walk down the side of that crater and up there from whatever distance on there? Because you go back and look at Apollo 15, 16, 17. YouTube has hours of that footage on there. I'm fascinated by it, Steve. I love watching it. It's good background noise sometimes to me. They're exploring. Sometimes you get the astronauts are kind of fussy with each other about things in there. But so it's human drama that we missed out on, I think, on this when that camera messed up.
And one of the problems is, again, when you're looking at all of this, everything is live, mistakes are live again, and the other problem was the time of day. We can't adjust the time of day when these things are going to be done. You can't say, well, let's do the EVA, the moonwalk at 8 o'clock Eastern time, so we can. It is what it is.
Instead of 11:30 at night. Like
Exactly.
Apollo 11 was. Well, let's get through your list here.
All right.
Very comprehensive list, and I appreciate Steve putting things together here. It shows you all out there the just the thumbnail sketch. Think of what the astronauts had on their wristbands and so forth of their tasks out there.
So if you look at these at home and you get a chance to replay these things, you can see all the details. What I did in red is for the benefit of the broadcaster to give you an idea of how do you put these things in a summary. We had to deploy all the lunar experiments. In this detailed part, you can see every single experiment. And we'll get into that a little bit later. More surface core samples, more gas analysis. Every one of these things we have a chance to do, we couldn't do on Apollo 11. Apollo 11, a few simple experiments. Again, one was just a mirror, so you can measure the exact distance to the moon.
The solar wind experiment
solar
was
wind
a piece
experiment
of aluminum foil
exactly.
on a stick.
Very, very basic. You only had a little over 2 hours to do something. Here we have multiple hours on 2 moonwalks. And we have that solar wind experiment as well. Excuse me. To give you an idea of what this looks like, we have that lunar module there pretty much in the center of your screen. The first EVA, that was Intrepid, yeah.
Intrepid,
you'll notice the patch had the sailing ship. You can see that in the upper corner of the projection
Hawk.
here, right? And Yankee Clipper.
Yankee Clipper, I mean, yeah.
And what you had is Yankee Clipper as the command module, and Intrepid as the lunar lander, which is why they had the sailing ships. And again, all 3 of the crew members were Navy, so they used the colors, blue and gold, the Navy colors, as the patch. Now, the lunar module there, you can see in the center, the LM. EVA-1 went off to the upper left-hand corner of your screen, and you can see where they did the traverses. At the bottom is a little scale, show you exactly about 200 meters or somewhere in the neighborhood, how many feet, a little over 650 feet or so, and you can see how close they actually got to Surveyor 3. So that gives you an idea of all the time they had to walk around and get back to the lunar module.
Pinpoint landing. Excellent
pinpoint landing
by Pete. Yeah.
I think the one classic picture, other than the lightning, for this flight, was this photo right here. That's Pete Conrad. You could actually see the lunar module there in the background with the deployed antenna. Mm-hmm. And that's him on November 20th of 1969, coming up on 56 years. Surveyor landed on the moon on April 20th, 1967, about 2.5 years before. So that's Pete. And one of the things they were going to do, and Pete was really upset about this, I don't know if you knew about this, is they were going to they had a tripod, mm-hmm. and they were going to take a remote control picture mm-hmm. of Pete and Al standing mm-hmm. and have a picture being taken. And all of a sudden at home, people would wonder, wait a minute, who's taking the picture? Mm-hmm. But unfortunately, they couldn't find the remote switch.
Yeah, Al Bean had it in one of his pockets, and he just couldn't pull it out with that gloved hand. That was the Hasselblad self-timer that he wanted to put on there. And I'm kind of glad they didn't do that for all these
for all the hoax wackos out there. The host spoke,
in there. But we're going to show you a couple pieces of this that were taken off and brought back. That I've seen,
the program,
I've seen one with my own eyes. The camera right there beside Pete, that tube is the Surveyor camera. That's in the Smithsonian. In the scoop that tested and scooped up soil to test the tensile strength and so forth is in the Cosmosphere in Hutchinson, Kansas. Yeah,
okay.
That's one of the iconic images of the Apollo era for sure.
Yeah. Okay, one of the other questions. Yes, we do still get people that come out to the Space Center and say, I don't believe we landed on the moon. So I included this photo.
My answer to that is, if we didn't land on the moon, I want Marty to give back all the money that Grumman paid him, all right, to fake the moon landing. But he won't do it. He won't even consider it.
Well, we also get occasionally, I've only had two of flat earthers People that believe the Earth is
Oh
flat.
yeah, flat earthers.
And that was a real surprise, but I came up with the answer that I used for them.
Okay.
What I usually say to them is, really, you think the Earth is really flat and this isn't going to convince you? No. I said, well, let's look back 500 years. You remember Columbus? And they'll say, yeah. I said, remember when he came to the New World with the 5 ships? And they usually look back at me and say, 5 ships? I thought it was 3. I said, well, 2 fell over the edge. And then they'll just look, and it's like, you trap them into that.
Yeah.
Yeah, I mean, there's just certain things you can't.
Well, we always say if the Earth was flat, cats would have knocked everything off of it by now.
That's right.
On there, but why isn't there a flat moon or flat Mars?
Yeah.
I mean, it's just the flat Earth.
So these pictures.
But Lunar Reconnaissance Orbiter, we love it, and also.
Right.
There's a Japanese orbiter, and that's been taking pictures, I think, or Israeli orbiter.
Well, we have the pictures you see here.
That's so cool. Look at the
That shows, you can see the Intrepid descent stage. That's when the lunar module lands, it has 2 stages, the part with the legs and the part that has the astronauts. The astronauts go back, but the descent stage, the part with the legs, stays on the moon. And there's a picture taken by the Lunar Reconnaissance Orbiter of the descent stage. It also shows where Surveyor 3 is, right there, in Surveyor Crater. There's Head Crater. And you could actually see the little streak marks of where their footprints are. And again, with no wind on the moon, you put a footprint there, it's just going to stay there.
Mm-hmm.
So you can actually see everything, all the different moonwalks, where they went, and the vehicle's still on the surface of the moon.
At least for a million years till micrometeorites beat them
exactly.
down. But and we have these pictures, even getting closer up pictures of this. And just a little note there, Lunar Reconnaissance Orbiter, you have theirs launched in 2009 for a 3-year mission.
Still active.
And it's NASA's vehicles either break down right away or they last 10 times beyond their lifetime. It's amazing.
Now, I've tried to pick a couple iconic pictures of Apollo 12. The most iconic one we already showed you, that's Pete with Surveyor 3. On the left-hand side, there's a nuclear generator. It had a snap generator on board, and that was providing power for our instruments. On the right, you see the deployment of the American flag, the antenna being set up as in the lower left, and then finally bringing that big equipment, moving it around on the surface, learning how to transport things. And if you look at that photo, you can see way in the distance is that antenna. So you see they had to carry these things a good distance away. That is one of the things, how do we operate on the moon? And that is one of the things we had to learn on Apollo 12, because the upcoming missions are going to depend on how we learn to actually work in the lunar environment.
1/6 gravity, so like a big barbell there that he's carrying those experiments out there. I believe that was Bean's job.
Right. Now, looking at those science experiments, that's a picture of what they looked like on Earth. There were 6 main experiments on Apollo 13. We measured the lunar dust and radiation after long periods of time. You had that nuclear power supply that's going to operate for a long time. Again, a nuclear power supply. The moon has a half a month of light, half a month of dark, so 2 weeks each way. Nuclear power supply, doesn't matter about that. It's powered on nighttime and daytime. We have an experiment to look at the lunar dust and analyze the ions to study the moon's thin atmosphere. 2 experiments that were related to each other to do that. We have the solar wind, something like we had on Apollo 11. A magnetometer to measure the magnetic field, a very, very weak magnetic field and its interactions on Earth. And then the passive seismic experiment to detect moonquakes. Now, when they set up this experiment, I suppose one of the things they were surprised with is that they could actually notice when the astronauts were moving, that it shook the ground enough. Now, one of the things that's very unusual is for the early missions, for Apollo 8, for Apollo 10, 11, and 12, that third stage, people don't realize it. When that third stage, when you escape Earth's gravity, that third stage isn't coming back anymore. It's going. So for Apollo 8, 10, 11, and 12, it ended up going on a big, long orbit around the sun. Things changed on Apollo 13. What did they decide to do? They decided we wouldn't put it into that useless orbit. We'll hit the moon with it. Why are you going to hit the moon with it? Well, you know how big that third stage is because you built it. You know how fast it's going because you're tracking it. You know how much it weighs. And you know where it's going to hit because you're aiming it. Once it hits the moon, now you have that seismograph on the moon. It can pick up how long does it take those signals. Every type of material you have transmits those waves at a different speed. So, different elements. You could tell what the inside of the moon is like by looking at that. So for Apollo 13, 14, 15, 16, and 17, we impacted that third stage on the moon in different areas so we could see what the inside of the moon was made of in those different areas.
Mm-hmm.
The joke was
seismographic
right,
data being
exactly. And that was one of the jokes on the patch of Apollo 13. It says ex luna scientia, from the moon science. And they joked that, well, the crashing of the third stage was the only science experiment that they actually worked.
Yeah, there you go. Yeah, well, that's interesting that we got that out of it.
All right, this is a picture of the Apollo 12 site with the ALSEP package laid out. The part there in the upper center, that is the main device, the central station that sets out the telemetry signals. You can see the wiring going from the different devices that would turn back to Earth. And then
56 years later, they're
yeah,
still there. Are some of these still working?
I don't know if some of them working. I can't imagine that they'd still be working. I know they worked for a certain amount of time. I don't believe they're still working.
Okay.
And then you want to look at the science results. What did we learn? It did detect the moonquakes and other vibrations, the other vibrations of the crew, and information about the internal structure of the moon. So again, something else we didn't know. When we had Apollo 8, the very first spacecraft we sent in orbit around the moon with a crew on board, we noticed there's something called mass cons, or mass concentrations. So the orbit was disturbed a little bit, having to locate where these areas are so we know how we can better plan for these little disturbances in their orbits. The solar wind, that's the particles coming off the sun. We had to figure out how does that work with the moon's magnetic field. The thermal ions that are coming out as well. Learn from the science of that. The environment itself of these devices. How do they respond after a continued period on the lunar surface to better understand that environment? And again, the period would be at least over a year. So I don't believe they're still working, but it was supposed to work for at least a year. And then just the fact that we're setting up these experiments to gain a network of how do you get all these things coordinated, getting project scientists. So again, if you look at Apollo 11 as just landing on the moon, do a few quick things and get home, Apollo 12 really set the stage for the rest of the Apollo program, which is why I think it's one of the most important missions, because everything we learned on that mission directly applied to everything else coming up down the future.
Very good, very good. Steve Agid there doing his usual thorough look at the Apollo 12.
And just one more to go.
And Marty, I see a question there. Do you see that question from Mostly Parked for you guys?
Now, did the LEMs impact the moon after separation from the command module?
Yes, they do. Yeah, the LEMs are sent back into the lunar surface as well.
And another question from Mark Thal.
Yeah. If we were to revisit one of the Apollo landing sites, could the LRRs be used to pick a landing site?
You talk about the LR cube, the range retro reflector?
I don't know what he's talking about.
Okay.
Yeah, I think if we were to revisit them with the reflectors.
The reflector again tells us the position of the moon. We sent a laser beam out from Earth. It took a few days. I think it took like 4 or 5 days for Apollo 11 for them to actually find the retro reflector. But after you find it, you found out that we can determine the distance to the moon to about 6 inches, which is incredible when you're talking about 250,000 miles away. One of the questions that I think you might be referring to are people who are always asking, well, if you got back to that site, could you take some leftover fuel that's in that tank that's been sitting on the surface for 56 years and, use that fuel for something else? The flag is one of the questions we get all the time. What would the flag look like? Well, they weren't meant for long-term stays, so chances are the flag may have been bleached white by now.
But you ever seen a red sign in a shop?
Yeah, after a long period of time.
But there is evidence by shadows of the pole and the flags are still there.
Yeah.
On a couple of them on there. Good question. Good questions there, Mark Thel. I'd also add that using the lunar reflectors to re-land on a site, boy, that's 60-year-old technology.
Yeah.
They wouldn't use that.
I'd say it's very. I said it's.
When you see the technology today landing a first stage booster on a drone rocking in the ocean that they've done over 500 times. Now they're not going to use those reflectors.
Yeah, again, that's for just a general, distance to the moon. Again, we would have devices. We had even on the lunar module itself, it did have a landing radar that it used when it got closer to the lunar surface. So again, I can't imagine, they wouldn't use the device that's just good for, this long distance measurement.
And Marty, of course, is an expert on that. Marty, you this was LEM number 6. You have any fond memories of it when you were scurrying around inside of the ascent stage doing your electrical thing?
No, I can't say I have any fond memories of 6 versus any
But
other
we've done
ones.
we've done several shows with your Grumman friends. We call them Grummies. Did you put your names in Apollo 12 in a hidden place like y'all did for Apollo 11?
No, we only did it
See that
one
just
time.
quickly the shine went dull on these things. You didn't do anything like that to like, well, I'm gonna put my.
When you figure several people could have lost their jobs when Rocco Patron found out what we did, we were not about to do it a second time.
Right. Oh yeah, they got in trouble big time. Those were George Skurla's Angels got in trouble for putting their name on a piece of what was it, Mylar?
The Mylar, yeah.
With a special acid signature pen, or what was? What'd you write?
It was like ink that you could use. There's other things written on the vehicles, just little codes. Nothing sneaked on. It's just
Okay.
the location type things.
So you didn't put Kilroy was here or anything like that on number 2.
No, did not.
For the second time, Marty Winkle's on the moon.
All right.
Well, that's just that just shows you, the excitement of it. Doing it twice with President Kennedy's pledge, I thought was just incredibly amazing, and should have sent a stronger signal to the communist world that we can do anything we want to do when we want to do it. So
okay, and to close out, a lot of people don't realize, astronauts are like everybody else in one respect, is they have that feeling of history. They actually work very well as a team. Now, we talked briefly about the design of the Apollo 12 patch with the 3 stars on the top, the one fallen star to symbolize Williams, who was originally supposed to be on the flight. One of the things that a lot of people may not know is that Al Bean became a painter, very, very good space painter, specializing in his moonscapes and such. There's a lot of big paintings all over. I mean, I have one in my office at home. But they took an Apollo 12 patch, and they took C.C. Williams' aviator wings and put them on the surface. So even though he didn't get to go, his wings got to go.
yeah.
The painting that Al Bean painted, which is what you see right here, he titled it Dedication. And I thought that'd be a fine way to end the presentation.
That's an excellent way to end presentation. And we're glad that we honor C.C. Williams today. Marty, go ahead.
Yeah, RG Jubilee is asking. She has a couple of questions. The last one was, where did Apollo 13 land crash? It was far away from the moon when it was ejected.
Okay, where was it supposed to land? It was supposed to land in an area called,
No,
I'm
no,
sorry.
where did the crash land?
The
Okay.
Apollo 13 landing occurred in the Pacific Ocean.
Yeah.
Okay.
I think she's asking, maybe I'm reading wrong. Where did Apollo 13 crash? It was, well, maybe you're right. I'm
Yeah.
sorry, Steve. Yeah.
Yeah. Apollo 13 had to return to Earth, and we needed to keep both stages together. Now, the aiming was to try to put it, since it did have a nuclear power supply, just like Apollo 12 did, and all the subsequent missions, they wanted to make sure it landed in an area with a very, very deep part of the ocean. So that's where the landing spot for the LEM was picked, in one of the deepest areas of the Pacific Ocean.
There you go. And also Tommy Usiak's asking, them Snoopy's still in a heliocentric orbit around the sun.
Now,
And astronomers trying to locate, they have located
yes,
it.
I
They're
believe so.
following it. It's going to come by the Earth in a couple years.
Again, yeah, why didn't you crash the Snoopy into the moon? The idea is, well, since Apollo 10 didn't land, there's no seismographs. It would have served nothing. So it's just in a long looping solar orbit right now. And I believe a few years ago that they did locate it.
Yeah, absolutely. And there's some conjecture that somebody may try to rendezvous with it, with a space tug, aka SpaceX, and bring it to Earth orbit or something like that. But very interesting. Al Bean, if you don't know his paintings, awesome. In fact, Al Bean was the premier space painter in this century. Passed the torch on to our friend Chris Calley, and actually told Chris, you know, it's yours now. And we've got Eileen Collins montage. Chris just sent us in the room in there. Well, put a button on all this stuff here. There's the landing and a moon rock, and yes, they were quarantined. Okay. Many of you don't remember that they landed in the ocean with 3 parachutes there. And they were worried about moon germs. And I thought back in the 1960s, my God, there's no virus or germ that could go around the world and kill everybody. And then, of course, you know, COVID-19 happened on there.
Well, no, one of the things they were concerned about, there were some protests at the very, very beginning of the program for Apollo 11. People had said we ought to keep those astronauts isolated for the rest of their lives.
Oh, really?
And I said that, well, so why did they pick 21 days? And that's very interesting. It was 21 days, not 21 days after they got back to Earth. It's 21 days after they left the lunar surface. And it turns out most diseases that people have, none seem to take more than 21 days to affect your body. So the idea is, since the gestation period for a lot of these diseases are less than 21 days. Interesting story about that. They did inject lunar material into lab rats and things, and to see, okay, let's see what happens to the lab rats, and everything was just fine.
Everything was fine.
But just to be on the safe side, the first 3 missions, 11, 12, and 14, again, not 13 because 13 didn't land, 11, 12, and 14 did do the 21-day quarantine. From 15 on, we did not.
And so where is the command module named Yankee Clipper? Where does it reside? Where is this?
In Virginia.
In Virginia.
Yep. Hampton, Virginia. That's what you're looking at right there.
What museum is that?
I had it there before. I think it's something like the Virginia Space Museum. That might be the exact, not the exact word.
Where
But
the
that's close
hatch
enough.
is. They ripped the hatch off that baby. The hatch isn't there. But anyway, you can look inside a little bit there. I've not seen that. Maybe some of you have. And Mark Thel notes that the crews actually took quarantine time to debrief and fill out the pilot reports and so forth. Do the paperwork. There's the
camera.
lunar surveyors. I remember just looking at the newspaper and magazines of these pictures taken with this camera. They would do a bunch of pictures. They put them together as a panorama. And there's the scoop. At the Cosmosphere picture that I took there, just looks like something you'd make in shop out of some heavy heavy, light gauge steel there, folded over a few times and whatnot. But you're looking at something that was on the moon at the Cosmosphere in Hutchinson, Kansas there. So, and I encourage all of you, if you want to get a good laugh, look up on the YouTube channel you're looking at, go at the top and put in Apollo 12 parody like I did here, and you'll see everything from the Three Stooges to Beach Bikini in this. And you saw it. What did you think of it?
Well, like I said, I got a kick out of it. The one I really enjoyed, and it's something that was given to Gene Kranz, and it was about Apollo 13. If you saw the Apollo 13 movie, there is a video that you need to see, because they say the Kranz family plays it every Thanksgiving.
You told me about
It's
that.
called Thanksgiving at the Kranzes, and it goes through a problem that they had cooking the Thanksgiving turkey, but it's based on the Apollo 13 movie. It's a parody as well, and it is very well done.
Thank you very much there. And somebody commented that they recognized your voice from maybe United Launch.
Yes.
Alliance commentary.
It's funny.
I'll have you thank our guests in your booming radio voice.
Okay,
there.
well,
But go ahead, you were saying.
All right, so the one thing I get a kick out of this, I once had a person on a tour bus, and they said, "You know who you sound like?" And I said, "Who?" It says, "You sound like the guy that does the countdown." And I said, "Well, from 2004 to 2016, I was either the countdown or the launch or plus count commentator for Boeing or United Launch Alliance, depending on when this was." And I never thought of myself as having a distinctive voice, but a lot of people say, yeah, you have a very distinctive voice. So let's take a look at these names, and if I mispronounce them, it's because I just was given it here.
I'll correct you.
And you'll correct me. All right, let's try to do it in that voice. Tom Musiak, Steve Jokums, Carlton Bailey, Dave Strange.
Stangy.
Stangy. Okay, Stangy.
Stangy.
All right, Gary Drell. Okay, Dean Babcock, R.G. Jubilee,
Yep.
Mitch Rothman, Tom Celentano, Freeway of Others, Doug Forrest, Cliff Watson, Mark Thiel, and Mostly Parked.
Thank you, my friend. Always
you.
a great program. I appreciate how prepared you are always, and not that I'm not, but
No.
not on this. You just amaze me with some of the great tidbits that you came up with. Got his Keep Calm and Set SCE, the AUX shirt on there. If I found mine, it probably wouldn't fit me.
Well, the one
mine was red. I remember.
The one thing I would say about the broadcast we did today, Mark, I think we had more questions on this broadcast than any other one I've ever done.
Good.
So that's great.
And
We
that
love
is.
that.
And maybe we'll just put you on and have people ask you questions about your career and other things like that, and dealing with the public, because we really appreciate you spending your time. It's important outreach for the American Space Museum. And I know you spread the word about our events and so forth, so we appreciate that. And yes, I am dressed in layers. Tell people how cold it was for Floridians.
Well, this morning, it was about 38 degrees when I woke up. And before I forget, there was one fella that asked the question I did not know the answer to about why didn't they use Jim Irwin, if I'm not mistaken, as the replacement, and why Al Bean. I will have to find that out, because things like that bother me until I find out.
All right, and that's Tommy Usiak.
Oh,
must have
okay,
known
very
that.
good.
And
All
he's
right.
a good friend of ours, and I'll pass that on. Marty Winkle, great show, and you've got another comment or question from our highly intelligent fans out there enjoying today's Stay Curious about Apollo 12.
Yeah, question from Dave Stangy. Did you talk about the actors playing the astronauts when the camera broke?
Oh, I don't. Those were people. When I saw that, they had it. What they had in the studios, they had simulated people. For some reason, I remember the command module guy's name was Leo Krupp. I don't know why I'm remembering that after someone. decades.
Well, we
where
had
they had a
Scott
simulator there,
McLeod was a
Okay.
trainer for Grumman
and they
and lived around here, and he would simulate on CBS
okay,
with Walter Cronkite. Walter would say, "What are they doing now,
right,
Scotty?"
and they had to
he'd
show
say he was
as much
doing
as they
this and
could.
that,
Yeah,
so, yeah, that got real boring.
I mean,
as
you can only
a
do. I mean,
teenager,
you have no. You can't say, "Wow, look at that,"
So it
and
may have
not
been
know anything.
Scotty or
Yeah, I
other each
don't remember.
station. Only 3 TV stations:
Right.
ABC, NBC, and CBS, and each one of them had their own little.
And I know you had like
scenarios
on
there.
ABC, you had Jules Bergman as the
Jules
science
Bergman.
commentator, but they had people trying to show you. They had a view of the inside of the LEM. One of the things they did have in the LEMs, they had a TV camera so you could watch everything, but it wasn't shown live. They didn't want Mission Control to say, "Hey, look at that, look at that." They had a recording that they were able to make, and when they got back to Earth, you were able to see the landing from the inside. That's why you could see these cameras looking outside the window. They just didn't want to do that live. They didn't want Houston to be a backseat driver. So that's a little bit of a tidbit of information.
Yeah, James Gibson's excited that Apollo 10 lunar module Snoopy
It's still there.
could be a museum piece one
Yeah,
day
that'd be great.
in outer space, going up to the orbiting Hilton. Maybe you might have it in its lobby up there. I don't think they'd ever bring it back. There's no
Well, you never know.
re-entry. You never know.
Yeah.
Never know in this day. So thank you, Steve Agid, for taking your time to stay curious with us today. We'll have you on and do something in December. Think about what you
Okay.
might want to do in the month of December. That's, of course, Apollo 17. We will always talk about the Apollo program here. This is why the American Museum exists, is our wonderful Apollo workers that built it and built the Spaceview Park. And though we have passed the torch to the shuttle era, this is so important to American Space Museum and American heritage that we remember these brave men and all the women on the ground, men and women that pulled these miraculous moon landings off, and nobody has done it coming up on, 53 years will be Apollo 17, 1972, and nobody's been back, and I'm pretty sure you're going to have to learn Chinese if you want to understand the people who make it the next time, but hopefully not. Maybe we can get Artemis back on track. So,
Well, I said, if all goes well, we're just a few months away.
that's right. Artemis, and as if you, Steve was saying, possible New Year's Day rollout of Artemis 2 from
That's
the
the-
VAB to the pad.
And when
So
they say early in the year, that's about as early as you
that's
can
as
get.
early as you get. Marty, everything okay on our Streamlabs production? You did an excellent job today as usual.
Yep, everything's good.
All right. Well, tomorrow we're going to celebrate Hump Day with some more space history coming your way, and look and see what some news and views are going on. Maybe even do a little backyard astronomy. So until tomorrow, I'm Mark Marquette, thanking you on Veterans Day for watching. Stay curious, and saying that I can't wait to see you again to bridge the space between us.